Welcome back, learners. So as you have said before in Ed Break, we're going to go to our last concept for the lesson, which is now the evidence of a chemical reaction. How do we know if whether a chemical reaction has taken place? So these reactions that we're talking about, we need to be able to model them and see and basically build them up in terms of them using models or using the chemical formulas that we're finding from the periodic table. So to model these reactions, we are using the elements. Remember that these we can find in the periodic table, and then we can also use the modeling atoms using basically the balls that we can basically use for them to represent a certain substance. We can also use the chemical formulae, and then we can use all of these things and bond them in a chemical equation. Also, a chemical equation that we are referring to, that's now an expression that uses symbols to show the relationship between starting substances and the substances that are produced. Remember that the starting substances are known as the reactants because those are the substances that are participating in a chemical reaction. And then the substances that are produced in a chemical reaction, we know them to be products. So how do we then now model our chemical reaction? We know that in a chemical equation, we have the left-hand side, the right-hand side, and those two sides are separated by an arrow, which is our react to form sign. Now, on the reactant side, we can have more than one substance. If you have more than one substance, then those substances will be separated by a plus sign. The same thing applies to the right-hand side, that when we have more than one product, then those products will be separated by a plus sign. So, on this picture that we have here, we have an arrow that separates the left-hand side to the right-hand side. Now, on the left-hand side, we have the reactants, which is now a CH4 that is now reacting with the 2O2. Remember, these two substances or these two reactants are separated by our plus sign. Now, they're going to chemically bond or chemically react together to form, hence our arrow now, to form the CO2 and the H2O. We said that on top of these things that we had, we also have the subscripts and the coefficient. The subscripts are telling us how many atoms in that chemical compound we have of that substance. So on the CH4, the 4 tells us we have 4 hydrogen atoms in a chemical compound of methane, or the CH4. The 2, it tells us that we have 2 oxygen atoms. Then on the right hand side, the 2 also tells us that. Then these 2 again there tells us that in this compound of H2O, we have 2 oxygen atoms. 2 hydrogen atoms. However, there's still another number, which is the coefficient, the big 2, that is written on the left-hand side or at the beginning of the chemical reaction, or the beginning of the chemical formula, which is the 2 and that 2 there. So that 2 tells us how many molecules of oxygen we have. The 2 on the right-hand side tells us how many molecules of water we have. And in terms of the picture, we can see we have the CH4, we have the C, that gray C, then we have 4 hydrogens that are chemically bonded to the C. Then we have our oxygen atoms. Remember that oxygen is your diatomic molecule written as O2, and because we have 2 of them, O2 and O2 gives us 2O2. So that 2 tells us that we have 2 oxygen molecules. Same thing applies on the right-hand side. That 2 tells us that we have 2 water molecules. But then because there's a 1 here, an invisible 1 there, then we only have the 1 carbon dioxide molecule on the right-hand side. So that's how we can model our chemical equation. By using the chemical formulas, we can also use the elements and also the modeling atoms. We can use them and chemically bond them together to form or to represent the reactants and also the products. Not forgetting that in any chemical formula or in any chemical equation, we have the subscripts and coefficients that are the coefficients are used to balance the chemical reaction. Whereas the coefficients are not used, we are not changing them, they are determining the ratio of the bonding substances of the bonding atoms. Now, how do we then tell that a chemical reaction has taken place? We know how to model the reaction. Now, how can we then tell if this reaction has indeed taken place? Number 1, there needs to be a color change inside the reaction flask. So whenever we're mixing the two substances, the reactant in a flask, there's going to be a color change. So either there needs to be a color change or something else. So when there's a color change, we can then say that there was a chemical reaction that has taken place. Also, when a metal rusts, we can say that a reaction has taken place. When you see a metal that has rusted, we can also clearly say that, safely say that the reaction or a chemical reaction has taken place. So if it's not the color change, then what? There needs to be gas bubbles, or there needs to be gas being produced. So a gas needs to be formed. Now, we usually know that a gas has been formed when we see bubbles. So on this picture that we're seeing here, we are seeing bubbles escaping the flask. So because there are gas bubbles being formed, we can clearly say that a chemical reaction has taken place. Now, this should not be confused with boiling. And we know that boiling only happens when a liquid is heated to its boiling point, right? So a chemical reaction, we can know that a chemical reaction has taken place by either observing a color change or seeing the gas bubbles that are escaping from that reaction flask. If not those two things, then what else can be able to tell us if a reaction has taken place? When we can see a sludgy or a cloudy deposit or crystal forming. So as we can see on this picture here, there's that sludge that is being formed after the substances are mixed in a flask or in a beaker. We can see there's that cloudy substance that is being formed there. So we can safely say that the reaction has taken place if we see, number one, a color change, number two, a gas being formed by way of bubbles that are escaping the flask, and then number three, when we're seeing a sludgy or a cloudy deposit that is forming after having mixed the two substances. However, our other senses can help us to say if whether a chemical reaction has taken place or not. Now, what do we mean by those senses, or what are those senses? Sometimes a chemical reaction or a chemical changes can be smelled. So basically, sometimes when you're mixing the two substances, you can smell something. So because of that smell, we can then clearly say that a reaction has taken place. For an example, when a new substance that has a strong smell is being formed, when you are mixing two substances and then the product being formed there has a strong smell, then we can actually perceive the smell, and therefore we can say that a reaction has taken place. Also, other chemical changes can be felt. For an example, when a reaction produces heat, when you're mixing two substances and there's heat being produced there. So you can clearly feel the heat, and therefore we can clearly say again or safely say that a chemical reaction has taken place. And then lastly, some chemical changes can be heard. For an example, when an explosion takes place. When you're mixing two substances, as we can see from the picture here, when we're mixing the cesium with the liquid, we can see there's an explosion that is going to be heard even from a distance, right? So we're saying that color change, a gas being formed by way of bubbles. Number three, we can also see the cloudy deposit or that sludgy deposit when two substances are mixed, two or more substances are mixed together. We can also say smell the reaction. We can also feel the heat being produced from the reaction. And then lastly, when we hear an explosion after substances have been mixed together. So that's how we can tell if whether a reaction has taken place or not. If we can see any one of those mentioned, then we can safely say that in this particular reaction or in this particular mixing of these two substances or more substances, a reaction has taken place. Now, with that said, I'm going to stop here for now, and until I see you next time. Bye.